we're going to find what the tension force is going to be in these two cables. And so we'll call this we'll call this T1. We'll call this one T2. This angle here will be a 30-degree angle, and this right here will be a 15-degree angle. So we have to draw some forces here on this. So this right here has a weight of 250 newtons. We get that by multiplying the mass times g. That'd be 25 kilograms times 10 meters per second squared. And each of these tensions can be divided into an x and let me erase that, and a y. So an x and a y. Now realize that I've drawn these with distances. It didn't line up very well. I've drawn these with distances, but the forces are not necessarily like this. In other words, this is not moving, so the right hand horizontal x force is equal to the left hand horizontal x force. The two upward y forces have to equal the downward y force because we're not moving. The net force is 0. So what that means is I have two equations. Here, this is going to be T, oops, let me get color coded here. T2 sine of 15 degrees, because this angle here will also be 15 degrees. This angle here will be 30 degrees. And this will be T2 cosine of 15 degrees. And over here we'll have T1 cosine of 30 degrees, and this will be T1 sine of 30 degrees. So I'm going to make two equations here. I'm going to make a y equation, which means the two ups have to equal the down, so that means added together, T1 sine of 30 degrees plus T2 sine of 15 degrees has to equal 250 newtons. I have two unknowns there, so I need another equation, and that comes from my two red ones. And we know because the net force is 0, T1 cosine of 30 degrees has to equal T2 cosine of 15 degrees. All right, if we just put numbers in, this is going to be 0.87 T1 has to equal 0.97 T2, because cosine of 15 is 0.97, cosine of 30 is 0.87. So T1 is going to equal, let's do a little addition here, 0.97 divided by 0.87, and it's going to be 1.11. So 1.11 T2. What we're going to do is we're going to take this right here and we're going to substitute it up in the blue equation where we see T1, which is going to be right there. So if I do that, I'm going to get 1.11 T2 times 0.5, because sine of 30 is 0.5, plus Sine of 15 is 0.26. T2 equals 250 newtons. All right, so 1.11 times 0.5 gives me 0.557, so 0.56. So 0.56 T2 plus 0.26 T2 equals 250 newtons. That's going to be 0.82. So 0.82 T2 equals 250 newtons. Let me extend the page. And so I'll divide 250 divided by that number, 0.82. And I get basically 303 if I round off. So T2 is going to equal 303 newtons. All right, well, how do I get T1? Well, I just take this number right here and substitute it back in my red equation right there. And so T1 will equal 303 times 1.11, and I get 339.46. So we'll just say 339. 339. That's my other answer. And so that is how you do a problem with two unknowns. You have to get two equations and use substitution. There's probably other ways to do it, but that's the way that I do it.